No, this is a solution for instrumentation and controlled final exam. So the first question asks, reads, in the circuit shown in figure Q1, a potential divider is used to drop down the source voltage, which is this, to generate a lower output voltage, which is this. So the first part asks, calculate the ideal Vout. So it's a simple application of the potential divider formula, which is Vout is equal to, since this is across the 4K ohm resistor, it's going to be, let's just say that this is R2, this is R1, so it's going to be R2 over R1 plus R2 divided by Vout. Okay, so in that case it's 4 over 3 over 4 plus 2 times 10 to the power 3 times, sorry, in that case it's Vn, which is 12 volts. So it's a potential divider. It depends on the ratio between the resistance of this and this, of the two resistors. It's 2/3 of this, so it's 2/3 of 12, which is 8 volt. That's it. So the second question, the second part 2, if the output is connected to a with 4 resistor. So in that case, if we want to redraw this circuit or actually edit this, so it's going to be like this, another resistor in parallel that has the value of 1 kilo ohm. Okay, so now these two are in parallel, so we need to get the equivalent, our equivalent resistance. In that case, our equivalent is equal to, this is R2 or R2 star over R2 plus R2 star, multiply, that's it. So that's how we get the equivalent resistance of two parallel resistors. Okay, so in that case it's 4 plus 1, so 4 multiplied by 1 over 4 plus 1 is 4 over 5, يعني 0.8 kilo ohm, obviously. What is this? So now we found the equivalent resistors. The question is asking for the output, the new output voltage, the error in voltage. So obviously adding this capacitor will change the voltage output. So the output voltage, so in that case we have the new equivalent, the new R2 equivalent. So applying the potential divider formula, it's going to be R equivalent over R1 plus R equivalent, which is equal to 0.8 plus over 0.8 times plus, sorry, 2, which is equal to, so multiplied by, not, so like we still have to multiply by the Vn, multiplied by Vn. In that case it's multiplied by 12, and the result is it's going to be 3.4. 3.4, let's say 3 volts. Now what's the percentage error? So you see, like, do you notice the voltage drop from 8 volt? It was 8 volt first, and then it became 3.43 after adding a load resistor. So percentage error, the definition is it's gonna be actual value minus theoretical value over theoretical value, then multiplied by 100, then get the percentage sign. Okay, so in that case it's 3.43 minus 8 over 8 multiplied by 100%. In that case it's equal to minus 57%. So that's the error. So that's the second question. What else? Yeah, the third part is what does this demonstrate? Voltage. So I saw here the load voltage was invariably close to 4. So when you added 1 to the 1 kilo ohms resistance in parallel with the 4, it reduced the voltage, and made it from 4 to 0.8. So potentially this led to, since this is a ratio, the 0.8 over the sum of both resistance, so 0.8 over the sum of both resistors is much less than 4 over the sum of two resistors. Therefore, the voltage output will drop. So we can say that in that case, just give me a second. So basically we say that since this is a load resistor here, so unless this load resistor is much greater than the voltage divider resistors, the voltage drop will not be constant. So if we always want to provide 8 volts, then the load resistor has to be much larger than that of the potential divider resistors. So unless, yeah, load resistors resistance is much larger than the potential divider, what happens? The potential the new voltage will always change with resistance. So, okay, now, how do we fix this problem? Question 4, or part 4, Yeah, it says design and draw a new circuit using a Zener diode, which then could replace the potential divider. So adding a Zener diode so that we fix or we actually replace the potential divider. So the Zener diode should do the job of the potential divider. So in order to do this, we have to understand what Zener diode means. Zener diode. What is a Zener diode? Okay. So that's the symbol of Zener diode. Basically, a triangle with some sort of a wave, or let me go, and so that's the symbol for Zener diode. Okay, so what this diode does is basically it operates at the breakdown region. So if this is let me okay, so now if this is the IV curve, so this is voltage and this is current. This would be the behavior of the Zener diode, just like any other diode, except that it actually operates at this voltage, at this area. So what does that mean? It means that if you provide a voltage that is below Vz, or in the negative side of the Vz, so for example, say that Vz is equal to, let's say Vz is equal to 5 volts. So any voltage above 5 volt will not add up to will not increment basically. So what does that mean? It means that whatever voltage you provide, the Zener diode will only allow 5 volts. So to show you an example, here, so this is and there's a resistance here. Let's say that this is 10 volts and Vz is equal to 2 volts. So that's the characteristics of this diode. Now, 10 volts is much greater than 2 volts, especially that it's it's in the opposite polarity of it. So basically, now 10 volts is in that region. So if this is 2 volts, 10 volt would be in that region. So 2 volts, 10 volts. Let me just fix this. Oops. Sorry. Yes. So 10 volt is here. Say that 10 volt is here. So given the characteristics of this diode, the output voltage will always, and if you measure the voltage here, the out, it will always be 2 volts because this is the characteristic of this diode. Now, back to our question. So the question is asking for a voltage to replace the voltage divider, the potential divider with a diode. So now we know that ideally we need to V out has to equal to 8 volts from this part. So when we calculated it. Now, so what do? We have a 12 volt source. We can connect a resistance to the diode. Let's say we put the Zener diode, then a resistance of 12 volts. The resistance in that case is what? It's basically the load voltage. And this is the purpose of the whole circuit, is to provide voltage to